Welcome to the session of, in-memory computing meets Kubernetes. So I'm Tal Doron. I'm a solution architect. I'll be speaking in this session and hopefully might pique your interest. And if there are any questions, I'm here until the evening, and even after that at the meetup, I'd be more than happy to answer any question anyone has. Can you hear me okay at the back? Perfect. So before we start, a word about me, the company I work for. So I'm Tal Doron. I'm a solution architect. I work for Gigaspaces. Gigaspaces is a software vendor that specializes in in-memory computing among the other respected colleagues of mine here at the event. We specialize in mission-critical deployments and platforms at many kind of different verticals and customers. We actually have two products in our stack. One is more focusing on the in-memory computing, distributed multimodal computing, and the other one that kind of converges everything with analytical capabilities. So that was the introduction. Let's start with the question we're all asking. Why? So, in the past, dinosaurs, well, they pretty much roamed the earth, wandering freely, ruled everything. But that was a long time ago. Those dinosaurs, most of them, are not with us anymore. Most. A lesson here to understand is that not everything which is big and strong will last forever. So those of you who might recognize the image will recognize the idea of centric computers, very strong hardware computers. In reality, it's the dinosaurs of the 21st century. Those kind of mainframe computers, which I'm not saying it's not a bad thing. They're amazing. But I think we're looking somewhere a bit more to the distance, or should I even say we're looking even higher. As men, we're looking to the stars. We're looking to go to places, to expand. That's where we want to reach. And to get there, we have to pass through this, let's call it a tier, or somewhere along the way. This somewhere along the way is passing through the clouds. Now, I hope the analogy was clear, moving from something very centric to the cloud is something we all want to do. If we at some point thought we can avoid it, I think we're all in agreement now that it's where we're heading. So I'm kind of wondering, a show of hands if it's possible, how many of you are technical people, developers, architects? Okay. And how many of you have never touched any product related to the cloud? Okay. So it seems that this kind of journey is inevitable. And the thing is that getting to the cloud or moving your platforms and architectures and different solutions, moving it up there, it's a challenge. But the thing is that sometimes it's the small things that make the game changer, that change everything. I hope I'm not doing a spoiler here for anyone. And if I did, it's too late. So it's the small things. It's one action. It's one thing that you need to change. And if you're asking, so what does all this have to do with Kubernetes? It's because we need to find a way to ship men there. Well, I would say fly, but it makes more sense to ship there because we need a way to ship the applications from the on-premise to the cloud, to the hybrid deployment, to the multi-cloud deployment. And we were able to do that with planes pretty well, I think. And it's been over 100 years since we started doing it. But what happens with our applications? How do we move them to the cloud? What do we need to be cloud native? Well, there is a huge shopping list of what it means to be cloud native. You need to be able to manage large deployments. You need a unified API. Well, preferably REST API, which is very commonly found in most organizations. You need to be able to containerize and use some kind of an orchestration tool to deploy everything there. You need to be application-driven, event-driven. So many requirements. I'm already getting tired here. Well, you need to be elastic. You need to be able to scale up, down, in, out. I don't know if there is any other scaling methods, but you need to be able to provide all that. And you need to be able to monitor everything, collect all the telemetries, and, well, who knows, maybe even use predictions to predict Black Friday, Cyber Monday events, scale ahead of time. Maybe when it rains, you need to scale twice as much. I don't know what's the use case, but there are many other considerations, but I would say this is where we start out with. So, kind of assuming that, well, hopefully, I'm just wondering, anyone in the crowd that has never heard of Kubernetes? All right, I was worried that some hands will be raised, and then we have to go back. So, Kubernetes. What are we talking about? Why? How? When? So, we'll give a brief overview, not of the Kubernetes, but the incentives. We'll talk about how organizations are using it to automate deployment on hybrid, multi-cloud kind of infrastructure. We'll talk about, just very briefly, about some 3 open source tools that I don't want to say must-have, but I would definitely consider having there in the architecture. And also about comparing some cloud vendors. Right. Next person that passes here will have to deploy everything in 1 minute. All right. So, what's the story? The story is that we need to build a real-time platform to serve real-time needs, to actually solve a problem. But solving a business problem means that we need to solve it from the technical angle as well. So you have traditional kind of batch, overnight, intraday platforms. I'm sure everybody heard that pitch before. And the question is, how do we move to the more real-time, actionable, reactive, predictive, proactive, build this kind of cognitive intelligence platform? And not only that, we also need to blend the stream and batch operations together. So that's where we're focused. And before we'll go to the deployment, I'll mention the platform that we're using. And by the way, it's true to every platform that you'll be using. We're using a Gigaspaces platform. It's a distributed platform, run operational, transactional, analytical, processing. I know that you've all heard the term HTAP, hybrid transactional analytical processing. Everybody nowadays is moving to that kind of architecture. That and the decoupled HTAP, where you have the same platform on different physical servers, running analytical and operational workflows simultaneously at the same time. What you're getting from it: memory performance, SSD costs, use SSD, NVMe, Optane, Apache Pass, whatever you want to use. Integrated with data lake, cloud storage, Sounds amazing, sounds promising. But you say, okay, I want to do it. What's my first step? And the simplicity is part of the equation here. So what is my first step? So Kubernetes. Being used in over 50% of the Fortune 500. It is. It's very commonly used. And it's just growing. It's becoming the de facto platform of choice for orchestration. Market share-wise, I know the numbers show 50%, but every customer I visited is using Kubernetes. If you'd ask me, of the hundreds of customers I visited, I would say it's somewhere in the 90+% I've seen using. And in a few minutes, we'll see also why. So Kubernetes, number 2 project in GitHub for contributors' point of view. 400,000 users on Slack. Highly discussed project. Different flavors, anything from vanilla all the way to OpenStack and cloud vendors flavors. Everybody's playing around with it. Most organizations have already understood that's the orchestration platform of choice. So why? Why does it make it a platform of choice? Well, we'll touch on that, but I will already say the bottom line. It doesn't matter. It is a platform of choice. From business landscape perspective, well, we had a few different orchestration tools. I would say that Kubernetes pretty much won the race. You can still see some of them out there. But the fact is that all the major cloud vendors, I haven't checked some of the niche ones, but all of them have already moved to GA. You can use Kubernetes services. And if you're having cloud deployment, not using Kubernetes for deployment, it actually does make sense. Not to mention that most of us are using probably Apache Spark for their analytical workloads. Also, native Kubernetes support. And it's getting better and better by the day. So why? Why Kubernetes? Why do we want to use it? Well, Kubernetes is kind of a state-driven orchestration. You kind of define your desired state, and it will try to maintain that state, whether it's on the deployment, or when it self-heals, or when it rebalances. You define the state you want. You define the SLAs you want to maintain. And Kubernetes will definitely try and get you there. That's your ship. So some of the key building blocks in Kubernetes is a high availability architecture. Something fails, restart. Doesn't work, move it to another place. Multi-tenancy out of the box. Role-based authentication also. You get it out of the box. You get so many things in Kubernetes. It'd be crazy not to use it. I almost feel like I'm selling Kubernetes. But it is. So in a few minutes, we'll talk about auto-scaling and self-healing, and that's an important piece in every distributed platform and architecture. Without that, don't bother building a distributed platform. Diving inside the product, I will speak about the components themselves. What we did, we actually deployed a management pod. That management pod has 3 components: a lookup service, Zookeeper, and REST manager. the easy one, REST manager. Well, it makes sense to have a REST manager that can deploy your services and out-of-the-box services to easily manage and query the data sitting in the platform. Zookeeper. Well, leader elections, split brain. Well, as I mentioned, it's a distributed system. You definitely want to use that. Lookup service. So you can actually find the services you have, whether it's stateful or stateless services running within the platform. That's all deployed in a management pod. In a few more minutes, we'll see how many management pods we actually need. The second type of pod that is being deployed is a data pod. Now, why do we need that? Easy. We need to store the data. But it's not enough just to have the data in the platform. Because if we're going to build a classic 3-tier architecture application, we could just use a database. We don't. We want to actually deploy the logic to the pod, to be co-located with the data. So I think in other terms, we're talking about stateful services. So we have stateless services, stateful services, function as a service, however you want to call it. It's all deployed co-located. And we need another thing. We need a Spark pod. Because every time you submit a job, you need a driver pod, which creates executor pods distributed across the distributed platform. Well, that sounds like a lot of pods, a lot of effort. I know as a developer myself, building all of this, it sounds, well, quite complicated, and it is. That's why you don't have to do it. That's why using a platform is the right way to go, because that platform will take care of the software infrastructure for you. What you need to do as developers, architects, business owners, focus on the business. Focus on the logic you want to use. Not on the how, but on the what. So on a high-level overview, imagine this running on different machines on the cloud. We have node A, node B, and node C. Imagine those running on physical machines. Those, first of all, you can see the management pods. We have 3. Anyone can guess why 3? Not 1 or 2? Please, anyone? All right. Perfect. So in the past, looking at the CAP theorem, we would always push for availability and partition tolerance. But reality has faced both us and, well, everybody around us to use consistency and partition tolerance. And that is why we've switched to Zookeeper. So Zookeeper will allow us to maintain higher consistency rates than our previous mechanism. If you're asking why 3, well, because 1, well, it's not highly available, and you can decide if you have a split brain in this distributed system, which part, well, should remain active. 2, what happens if you have 1 in each part of the split brain? How do you know who is the active one? 3 is an odd number. It makes sense. The 2 that are left in the active part of the cluster, well, it's a majority vote, and that's the active part of the cluster. Of course, you can also have 5, 7, etc., but it's an n+1 high availability. You have to choose a number. If you want 5, it's also fine. I'm not familiar with architecture that have more than 5. So that's the management pod. Data pods. Out of the box, high availability. Unlike many other solutions, which some of them are amazing, which have also a primary backup notion, most of the solutions go with object primary backup. So you don't really know ahead of time or once things start to shift, where your primary or backup, where they actually are located. We decided to take a different approach and work with primary backup partitions. So the whole partition has a primary and a backup one. And hopefully with anti-affinity, which you can get out of the box with Kubernetes, they sit on different physical machines. Take it a step further. Let's use this distributed architecture to also deploy the Spark drivers and executors. Use data locality. Other lectures we have, we also dive deeper on how we use bucket techniques to actually accelerate query time over the data, which is already in memory and is already fast. But that's what we're doing. And that's a very small platform deployed here, system deployed, 3 primaries, 1 backup, easy stuff. How this kind of platform would look from a Kubernetes dashboard view? Easy. Well, this is something we ran locally. As you can see over here, you have 2 primary and 2 backups running in the grid. Monitoring via Kubernetes, monitoring it via other tools, via the REST API. We also have another API monitoring using the metrics which are automatically saved in a time series database to later be used Grafana for analysis, or not later, but actually business activity monitoring in real time. That's where we're heading with this. So some guidelines. Anti-affinity. One of the worst things you can do in any distributed system is deploy primary backups of high availability on the same server or the same rack or the same, well, something physical. If you can avoid it. Don't do it. And with Kubernetes, it's as easy as just setting the mode true. Also, if you're using a distributed system and you're deploying stateful services, you need to be able to maintain states. If you switch from primary to backup, if you scale, if you upgrade. And again, Kubernetes will give you that out of the box. Yes, there is some integration there, but it is out of the box. You don't have to build it yourself. And if you're using this service, you don't have to do anything yourself. So now you're probably asking, okay, all this sounds pretty magical. How hard would it be for me to actually install it? That hard. Now, if some of you have ever done any kind of integration projects, you all know that installations, configuration, deployments, those could take days or weeks. And that's what Kubernetes is. The aim is to reduce that time, the deployment, and of course, afterwards, the monitoring and scaling. So, yes, that's a naive installation. I just mentioned the product version. What happens if you want to install it like I showed you before with 3 partitions? What happens if you want to install it with, I don't know, half a gigabyte of memory per partition, or 30 gigabytes per partition, or 100 gigabytes per partition? What happens then? How complicated would it be? Very complicated. It's that complicated. And what about the high availability? We all know it's hard to build that kind of platforms. Or anti-affinity. How complicated would that be? Also, that complicated. Where are we going with this? If you want to start building something fast, and it's not just for development, you actually want to use whatever you're building to move it to testing, to production. That's the way to go. There is no other way. So you might be asking yourself, okay, that's great. So we got this car running, we know how to drive it, but how do we know when something is happening under the hood? What happens if the engine makes noise? I don't know, in my car, I have this beautiful LCD screen that if something is wrong, I have this picture of the car and the car component showing in color. If I don't have enough air pressure, I can see exactly which tire it is. I don't have to go out of the car and check every tire because I just saw a blinking light. I can actually see which tire. It's amazing. It's like the future technology. Seeing which tire lost pressure. I don't know, in Back to the Future, I've seen the tires, they blow themselves back up, but I'm sure we'll get there at some point. But what do we do with Kubernetes? Well, the thing is that we have two things. The first one is testing for liveness. Basically, it means that the pod itself is alive. The process is working. There is something to work with. That basically means that we don't have, or should I say, behind the scenes, the platform doesn't have to shut it down, the process, and restart in another location. It doesn't have to start out the primary partition and start another primary partition pod somewhere else. That's the liveness. But it's not enough. Even when I turn on my car and it's making noises, sometimes it's not the right noise. I'm not a mechanic, but I would recognize when something is making not the right noise. So we need the ability to test for readiness. So in this case, imagine where you start this platform, you deploy it to the cloud, you have this automatic initial load from the database to the in-memory compute platform. But what can you do? Databases are slow. Network, one of the worst enemies we have. By the time it will take the initial load, it could be minutes, could be long minutes. And in that time, you're not ready. So everything is functioning as it should, but you're not ready. And that's why you need to test for readiness. That's the green light that now you're ready to accept requests or start the computation. So you must be wondering, okay, so I can easily deploy. Where am I deploying this? Anywhere you want. On-premise, on cloud, on any cloud. Hybrid, where some of it is running on-premise, some of it is on a cloud, multi-cloud. And trust me, organizations are deploying in multi-cloud. Sometimes it's not for the same project, but from most of the financial organizations I meet, they're using different clouds for different considerations, sometimes cost, sometimes it's compute power, sometimes they have other considerations. And that's the way to be generic and use whatever you want to use. Build once and deploy many. But if I am deploying on multiple locations, what do I do with the data? Some of it is on-premise, some of it is a cloud. What happens when I have multi-cloud deployment? It's not one cluster. Some of it is running on Google Cloud, some of it is running on AWS. Obviously, it's not one cluster. Now, you'd be working in multi-cluster mode, very often in active-active. That's where you need a replication mechanism called WAN Gateway. Out of the box, another pod. WAN Gateway pod. It's easy as that. Have a delegator and a sink. So whatever is running on one cloud, you need to replicate all of it, some of it, filter data, enrich, de-enrich, do whatever you want. You can use the outgoing filter. And the actual example here is to replicate data from the New York site to the London site via the delegator, to the sink, write the data to the other cluster, And of course, if there are any conflicts, which could be in any active system, use a custom conflict resolution algorithm. There's a default one, which is pretty much the recent one wins, but write whatever logic you want. You can decide that always New York takes precedence. And if you're wondering how many customers are using this feature, I can tell you that a lot. And way before they became cloud native. So the next question is, okay, so we can deploy multiple clouds, we can easily move from development to production, but let's talk about production. What happens when something fails? So we all know that things fail. I know that. I mean, my previous lecture, it took us about 10 minutes to connect the computer to the projector. So things always fail. That's a basic assumption that we all have to understand. Now, understanding that, we need to design the architecture that can handle failure. So we have the notion of auto-pod failure. We already have high availability, management, data pods. Well, stateless functions, it's easy. You can just move them around. But what happens with pods that actually store data, that store state? So what happens if data pod B over there, what happens if it fails? That's a primary one. Well, it's easy. There's a failover switch. Now the backup becomes the primary. The application, the operational workloads, Spark, nobody even knew it happened. The platform took care of that for everybody here. Now, another pod is being initialized. If there is a problem on that specific machine, rack, or whatever, it could be started on another physical machine. Again, best effort. That is now the new backup. But it's not enough, because in this architecture now, we have the two primaries running here. So if the whole machine will fail, we're not losing data, but it's a state we want to avoid. And because we switched the high availability mode and the anti-affinity, and our desired state would be to have as less primaries on the same physical machine, there'll be a switch back. So we can avoid the situation where we have too many primaries on one machine. Usually what will happen, and we've seen it in the past, if I'm looking years into projects I've been involved in these kind of systems, that at some point you have one machine running at 100 CPU and a few other machines running with almost 0 CPU workloads. And that's because that one machine has been, I wouldn't say collecting, but starting primary partitions. And by the way, it's true to all the distributed platforms here. It's not unique to Gigaspaces. And that's how we avoid it, with this kind of architecture. And you're also asking, what about scaling? Easy. It's the same flow we've done before. Shut down the backup. Do not interrupt the primary. Restart it. More memory. Maybe on a different machine, depending what kind of scaling you want to do. Shut down the primary. Now the backup, which is larger, becomes the primary. Restart the backup. Copy the data to the backup behind the scenes, and you've scaled up. And the same for scaling down. Easy stuff. And I'm telling you this, it's a bit the behind the scenes. From your point of view, it's a command. Just do it. This is the behind the curtain, what's going on underneath the hood. Cloud vendors. all cloud vendors are GA, Kubernetes GA. I don't want to recommend a specific cloud vendor. They all have upsides and downsides. Google, they do have an auto-scaling, automatic updates for the Kubernetes deployment. Auto-scaling, Google and AWS provide you out of the box as well. I don't know, maybe in the past few days or something, others do as well. You can let me know if I got this wrong. Node pool, deciding where you want to cluster to exist, what kind of servers, multiple zones, different zones. If you want to install on bare metal nodes, you can do that as well. Well, on AWS and IBM at least. And we have customers that have done it for performance considerations. But the point is that whichever cloud you choose, you cannot go wrong with Kubernetes. Well, 3 technologies you highly suggest you check out. Prometheus, monitor everything. Everything is being written to a time series database behind the scenes. Use Grafana for the monitoring. Grafana, if those of you that are not familiar with, it's kind of like a Kibana tool to actually visualize the data in a business activity monitoring screen. So Prometheus, amazing project. Istio, service mesh. How do we enforce the policies you want between the microservices, the policies, the security, the deployment? Definitely look into it. Please, I urge you to do that. And Helm, which we're all using behind the scenes. Great package manager. You can write everything you need in deployment, in the YAML file to decide what is dependent on what, and all the dependencies in one file, so you don't have to write the commands every time. Amazing tool, and as I said, we're using it a lot. So you'll get a copy of this. There's a recorded demo, because we don't have time to do it, but if you want to watch a recorded demo, you can definitely do that. You'll get a copy of the PDF with the link. So just some commands to see what we're talking about. Installing the repository, Gigaspace's repository. As easy as that. Updating it, because we're listing very frequent updates to our platform. Searching the charts you already have. Fetching it. We found it works better with local charts, so it makes sense to download them locally. Installing a grid. Well, we already understood that that's not the hard part. Monitoring, getting the status, getting the pods. And by the way, if you're running it on your computer, you'll have to install Minikube. Using the REST manager, which you can obviously deploy your own RESTful functions over here as well. And then using the Gigaspace command line, also possible, as I mentioned, multiple APIs. Running a Spark job, also. Well, you're probably familiar with the submit. Quite easy to submit it to your deployment. And then you can enter to the driver pod and see the results. We have a demo for that as well, for calculating pi. Running an InsightEdge job, which is the product itself. It's very, very similar to running a Spark job, very similar. We try to maintain the syntactic as much as possible. So again, that simple. If you plan on deploying on your computer, feel free to use those examples. Zeppelin. Why would you need Zeppelin? Because you don't want to write code and deploy it every time you change one line. You want to be able to kind of interact with the data. You want to be able to visualize it. Why do I mean visualize it? Anything from querying it and seeing the results on the screen in an interactive way, all the way to actually creating reports and dashboards, because that's the best way for data discovery. with colorful dashboards. Failover. That's easy stuff to test. They'll start out with primary backup partition, kill one of them, and as you can see, that's the primary one and that's the backup. And they switch because the backup became the primary and it started the backup so fast you probably won't be able even to catch it. But you will see from the PID that it's a different process. So what is the bottom line here? The first one is don't write everything yourself. Use the right tool for the right job, whether it's Gigaspaces or anyone else. Check out the use case, see what you need to get it done, see what will get you there as fast as possible, but more important, think about the next step, the monitoring, the scaling, the updates, upgrades. Think about that part. That's the most important part of every project, because simply developing and getting to production, it's not enough. And that's why the world has switched to DevOps. Take responsibility for what you're doing and maintain it and support it, because it's as hard as developing it. And I think the bottom line here is that we're in the age of building spaceships. We got to space, but we're still trying to get to the clouds. And that's why I would highly recommend using Kubernetes. That is why we're using. And my projection that in the next couple of years, that will pretty much be the orchestration platform of choice using Kubernetes. I know that's where we're heading and where we're taking our customers. So I'd like to thank you for being here at this technical session. I know it's never easy to hear technical talks. And I wish everybody best of luck, especially in the deployments. And we're here for any questions which do not involve building spaceships. So thank you very much.